class, welcome back. In our previous video, we learned how to read a METAR, or a surface observation. So now we're going to use what you just learned and make a surface analysis, your first weather map. Now we're going to need a few things before you get started. First of all, you need a pencil with a good eraser. Then you're going to need some coloring pencils. In particular, red, blue, and green. Now, if you don't have coloring pencils handy, you can use crayons or markers, but coloring pencils work the best. All right, let's get started. In your Blackboard classroom, I have put a file called Surface Map, and it's going to look something like this. So I need you to download that and print it out, and then we're ready to get started. All right, there's a bunch of METARs on this map, and they can get close together and make individual numbers a little hard to read sometimes. That's just something that we're going to have to deal with and do the best you can. Another issue that we're going to run into is not all METARs have every single number available. Like the winds, that instrument may be broken, and so it's reporting the temperature, but it doesn't tell us what the wind is, or it may not tell us what the atmospheric pressure is. So those are just things that we have to work around, but we got lots of options, so we'll be able to make it work. All right, as we first look at this, the first thing I want you to notice is the wind pattern. Now over here in the northwest, the winds are coming this direction. But if you notice at the bottom, they're turning, going up this way. So in general, we've got this counterclockwise pattern, which if we recall from the atmospheric pressure chapter that we did, that is indicating to us a low pressure. Now, we can also look at our pressure readings and the center of that circulation, and we start to realize, oh, hello, Jedi, you're coming to help us. Thank you, baby. Move on over. Sorry about that. So we start looking at the numbers, the atmospheric readings up in this area, and we notice that the low pressure is centered right there, where the winds are making a tight circle. All right, so now that we've found our low, we're going to take our red coloring pencil and draw an L right where the low is. Now, I want you to notice right in this area, the winds shift. We go from a northwest wind to down here, the winds are much lighter and they're coming more from a southerly direction. That's telling us something's going on there. I'm going to tell you there's a front we got to find. So now start looking at the temperatures. If there's a big shift in temperature, that will give us an indication if we have a cold front or a warm front. So start looking at some of the numbers. Like right here, we got 64 degrees. And very close to it, we got a 56 degrees. And if you will look at those numbers, you're going to start seeing a shift. Like here, we go from 70 degrees to 57 in a very short period. So basically, where the winds start changing direction and that change in temperature is, we have a cold front. So you're going to get your blue coloring pencil, and we're going to draw a line where those winds shift and the temperatures change. You're going to draw little blue triangles on it. That is the symbol for a cold front. Think of these as icicles, and they're pointing in the direction the front is moving. Since the winds behind it are pushing this way, that tells us that the front is moving that way. Colder air is moving in. That's what tells us it's a warm front. Okay. Now, since our winds are kind of rotating around, you actually have warm air here that's pushing north. So that is a warm front. So again, you're going to look for that change in temperature. Let's see, for example, right here it is 69 degrees, and right up here it's 45. That's a sharp change. And again, the winds are shifting direction. Up here they're going this way, or here they're here. So you're going to draw a red line with red semicircles. Think of those as the sun coming up over the horizon. And again, that front is pushing that direction because that's how the general pattern of the wind is. The air is moving that direction. Warmer air is overtaking colder air, so that is a warm front. So there you go. A big part of the map right there, a low pressure and two fronts. That's the main part of it. All right, the next step is a little tricky. What we're going to do next is start drawing isobars. Now, if you recall, an isobar is a line of constant pressure. Iso means equal, and bar is the prefix for barometric. So, isobar, equal pressure. Now, let's start over here. I've got the first one started here for you. This line right here represents 1,018 millibars. Always label your lines because you're going to get a whole bunch of lines here and they're going to get confusing. So make sure you label them. Now, as I drew this line, there is a 184 here, a 184 here, a 196 here. These are the numbers with the highest pressure on the entire map. When I drew this line, everything higher than 118 millibars is on the inside of this line. Everything lower than that is on the other side. So you're going to do a little bit of guessing here. You got to take what you got here, like there's a 184, there's a 166 here. We know that's lower than 118, so it's going to be on the other side of the line, outside the circle, if you will. So you're going to continue to do this. You're going to make a line for every 2 millibars, so basically every even. We started with 118, then you're going to go to 1,016, 1,014. You can also start with the lowest atmospheric pressure, in which that's obviously going to be around our low. Basically, we got a closed circle. The lowest pressures I see, there's a 055 here. That's 1,005 millibars, 0.5. All the 050s, basically, 056, 055, and here is a 060 that is actually on our 1,006 line. So all of the lower numbers are going to be within this circle. I also did another one, 1,008 millibars, and again, anything lower than this is going to look like 008 or less. It's going to be within this loop. Now notice how jagged it is. And it's a little bit of subjectivity to it because either we can't read the reading or it's missing. So do the best you can. But I hope this also gives you a sense of how forecasters can get something wrong. Now, luckily, we don't have to do these surface maps all the time, that we have weather programs to do it. And the software programs like to make things pretty and smooth it out. So you miss some of these kinks in the lines and stuff sometimes, which actually can be something significant. But the computer kind of throws it out. It wants to soften it and straighten that line as much as possible. So give this a shot. I hope you can see the little lines that I have made. That will give you a start. I am not going to count off if you get these wrong. Again, I told you there's some subjectivity to it, and this is not easy to do. I just want you to try your hand at it and see what you can do. Now, I have completed this one. Lots of lines there. So again, when you turn yours in, I'm looking that you can find where the fronts are. You can find high pressure or low pressure. And give your hand a try at these isobars. Again, that's not critical. Don't worry if you don't get it right. You have to erase, try again. It's okay. So Now there's one last step to do in our surface analysis, and that is to locate precipitation. That's where our green color pencil comes into play. So, do you remember the little symbols like on our example METAR? We had a thunderstorm symbol. Well, some more symbols that you're going to see frequently are dots. All right. Right here in this location, there's 2 dots on this one. 2 dots, 3 dots. A dot indicates rain. 1 dot would be a light rain, 2 a little heavier, 3 heavy rain, and up to 4 is the max that you will see. Another one, not on this map, but you might see stars, the snowflakes. So that's pretty easy. All right, for precipitation, you're just going to look for those dots or thunderstorm symbols, that little zigzag with the lightning bolt. So just look and find those dots, and you're going to, with your green pencil, just do a little scalloped outline, kind of like a cartoony cloud, and fill it in. Again, that's a little bit subjective, so your shape is not going to be the exact same shape as mine, but it's going to be in the same general location. So that right there is your surface weather map. So we know we've got cold air coming in from the northwest. We got some thunderstorms here along the cold front, because you will learn that with a cold front, you're more likely to get stormy weather, rain for maybe a couple hours, but then it's gone. Whereas with a warm front, you're more likely to get light precipitation for a much longer time, because warm fronts are just more gradual. Cold air is dense, and so it's got more of a push. So cold fronts move faster than warm fronts. But we're going to learn more about what we call a mid-latitude cyclone. I think it's next week. So we'll get into that a little bit more. But I want to bring out one more point about our isobars. If you will notice in this area, the isobars are close together. Now that is going to tell us that the pressure gradient is changing a lot in a short space. And what that tells us is going to be stronger winds. So when the lines are more spread out, like in this area, you're going to have much lighter winds. So when they're close together, strong winds, spread apart, light winds. So those are some very important things that you can learn by looking at a surface weather map. Now, I want you to complete yours, and I also want you to print out another weather map. I've got a website, a link to it on our Blackboard classroom. Do that. You can pick any weather map you choose. That website will take you to a clickable map, so you can even choose which area of the country you want to try to do it. And if you have trouble with that, I can email you another surface map that you can do. But again, this is not real easy, the isobars anyway. So give it a try. Grading you on you doing it, not necessarily it being absolutely correct. Because for every meteorologist, there's that bit of subjectivity to it. So give it a try. And if you have any questions, give me an email, somehow let me know. So good luck.